Okay, so far we've been living in a world called exponentials. You do b to the x and it equals some number y. An example of this is like 2 cubed is the same as 8. That's exponential world. But there's another world that we need to start getting into called the logarithm world. Logarithms are a way we've invented to solve equations that involve exponentials. So more on that later. If we rewrite this, we're going to write this log base b of y equals x. Okay, so one thing to keep in mind, the b is still the base. This is the base of the exponential. This is now the base of what's called the logarithm. And then you'll notice x and y switch sides. So example, this guy right here, if this was changed into a logarithm, we'd do log, the base is 2, and instead of having the 3 on the side, we now have the 8 on the side, and we would have 3 come out the other side. Okay? Now, the reason we want to do this is because we'll start to encounter equations like 2 to the x equals 12. Now, 2 to what power would be 12? It's not going to be an even number. And so we've invented logarithms to figure this out. So if I change this into a logarithm, we would be doing log base 2 of 12 equals x. The base stays the same, x and 12 change spots. Now this we'll eventually be able to put in a calculator, and that would give us our answer. So let's do a few more things with this. Just a note, first of all. When you have just a plain log like this, of say like 50, what this means is that the base is 10. You'll see a log button on your calculator. That means you're going to be working in base 10 automatically. There's also this idea of ln. Say you did ln of 50. What this is actually saying is that it's the log base e of 50. Remember e? E is like 2.718 something something something. So this is this log base e, this ln is the opposite of e to the x. These go together. So, for example, let's say that you wanted to know e to the x equals 5. Well, we can translate this. We're going to do log base e, but wait a second. If it's log base e, we actually want to write ln. And then we're going to switch 5 and x. Now, we go from here to here, and then once we reach this spot, we can actually put ln of 5 in our calculator. So, going to our calculator, ln of 5 is the same as, well, it's approximately 1.6094. So what this is saying is if in a calculator you do e to the 1.6094, what should you get? You should get 5. Okay, another one. 10 to the power of x equals 200. Well, we can't solve this directly, so we turn this into a logarithm. Log base 10, so I don't have to do it, of 200 equals x. So again here, log base 200, if I put that in the calculator, it's going to be approximately 2.301. So we're saying that if I do 10 to the 2.301 power, I should get 200. Okay, so that's if you're using your calculator. There are some that you can actually just do by hand. So, for example, log base 5 of 5. They'll just give this to you and say evaluate. So what you need to do is think of this like it's equal to x. We're finding x. And we're going to translate this back into an exponential. The base is 5 right here. You're going to flip your 5 and your x, so this is going to be b to the x actually. Sorry, I said b. 5 to the x, and that should be equal to 5. So just thinking about it, if you write it this way, 5 to what power will be 5? Just 1. Okay? Another example here, log base 10 of 1, 2, 3, 10,000. Let's rewrite this. So we're going to write it as equal to y, and then we're going to do a translation here. The base is 10, so it would be 10 to the power of y equals 10,000. Now, this is easy enough to think about. 10 times itself, how many times would be 1,000? 1, 2, 3, 4. So y here is 4. Now, it does get a little more tricky because you'll see things like ln of e to the negative 5. Okay, let's again let that equal x, and we're going to translate this. The base right here is e, so it's going to be e to the x equals what's inside. Now, when I translate it like this into exponential, x has to be negative 5 so that they would match. So, there's another thing that you have to be careful about. One thing that you need to know is that when you have something like 10 to the square root, that is the same thing as 10 to the 1/2 power. Whenever you have like an nth root of something, that's the same as if you have that something to the 1 over n power. So, for the example here with a logarithm, if you set this equal to x and translate 10 to the x equals the stuff inside, x will be 1/2. But if you left it as square root, you would be kind of stuck at this spot here. So just keep that in mind.